Hey guys, today I'm going to talk about a new transmitter I've been using, calling essentially a Gemini transmitter, and we'll talk about this guy soon. But before I talk about what it does, I thought I'd just give a bit of a background about our current receivers that we have in ExpressLRS, stuff I've been playing with over the months, and then what I've just recently had a chance to go and test at a race event. So talking about reception with our receivers, when we first started off we had these monodiversity single antenna receivers, and these guys here are allowed to have, say, one chance at receiving a packet. You've got one transceiver on it, and when a packet is sent from the transmitter it gets one chance of receiving it, and if you get interference in that packet you may lose your packet and not receive it at all. Then we started to have things like antenna diversity. So here's one of the first DIY ones. I don't know if we can see that. And then we started to get diversity receivers with RF amps. And they're great because you can now have two antennas, and you can have antennas set up in different polarities so that you can switch between them, and depending on the orientation of your craft you may get a better chance at receiving a packet. But you're still only getting a single chance at receiving your packet. And you need to take a bit of a guess on which antenna you should be receiving on. So if you still get a bit of interference coming through with a packet, you may not receive the packet, or the receiver is actually listening on the non-optimal antenna. You may not get your best chance at receiving the packet. So now we have our first, what we're calling true diversity receiver from Happy Model. And this guy here has, on it, we have two radios, and these are our RF amps. So it simultaneously listens for the one packet coming through. So you have your two antennas, different orientation, and you can have double chance at receiving your packet. That's great, but you're still receiving the one packet. So if you get interference during that one packet transmission, you may lose it. ExpressLRS introduced something in version 3 called DVDA, or Deja Vu Diversity Aid, and it allows you to do repeat packets. It's great to try and maintain a high LQ. So whether you're using a single antenna, dual antenna, or true diversity, depending on the D mode using, D500 or D250, you may get 2 or 4 chances at receiving that same packet. So the D modes work by sending 1,000 packets per second over the air, and if you're using D500, it'll send the same data twice, and it will send it on 2 different frequencies. So between the sends it'll do a frequency hop. So hopefully it's going to dodge any interference that's on one of those frequencies, and the repeat packet will get through. For D250, you're getting 4 repeat packets, and during those sends you are doing 3 frequency hops. Well, not 3, you're doing 2 frequency hops, and you're sending it over 3 different frequencies. So it sends the first packet, does a hop, sends another 2 packets, hops to a new frequency, sends the 4th packet. And that gives you a very good chance at receiving your packet. If you're using it for racing, you're essentially going to have a locked LQ of 100. D500 can still dip into 99 every now and then, but it does a great job at dodging interference. The downside of using the D modes is that you're cutting your packet rate sends every time you want to do a duplicate. So we will start with 1,000 Hertz. If you want to do D500 and send a packet twice, you're now down to 500 Hertz. What I've also been playing with to try and help this was a transmitter with 2 antenna outputs. So this here was a prototype iFlight module, and they happened to use a RF amp which had 2 antenna outputs, so I hacked in a second. And people may have seen me teasing that on Facebook. My TX16 with 2 antennas, and that was a fun experiment, just looking at how does LQ change flicking between the antennas. Why should you flick? I didn't see a huge difference particularly for racing. I just do close range. Not a huge improvement there on LQ, if anything at all. For long range guys, whether or not be beneficial, don't know. They're mainly flying in a single orientation. But once again, you're only sending one packet. You send that one packet on one of the antennas, and if you have any problems with interference, it may not get picked up by one of your receivers. So, Gemini Mode. What are we doing with Gemini Mode? Since we have our true diversity receivers, which have 2 radios, why can't they listen on different frequencies? So, instead of listening for the same packet on the same frequency, let's send 2 different packets or 2 packets on different frequencies. And the first prototype of this, I was in my trusty TX16, and I stuck in one of the Happy Model receivers, stuck it in as a internal module, and this guy allows me now to send the same packet simultaneously over the air on 2 different frequencies. So what are the benefits of this? Well, if the editor of this video does his job correctly, you should be watching some race video, and the race footage should be showing you what's happening when you're using a single transmitter going to a receiver with a single antenna, and you should be able to see the LQ, and the LQ in there will be bouncing around 90s, sometimes dipping into the 80s. And all of this DVR is based on 1000 Hertz. The next bit of DVR is showing diversity, so it's a single transmitter going to a receiver in diversity mode. And we should be able to see here that LQ is more in the 90s and hitting 100. So it's still bouncing around, but you are hitting 100, and the diversity receiver is doing a great job at picking it up. And of course, if you're using the D mode with one of these, it'll be doing even better. And the last bit of DVR is showing Gemini Mode. So we've got our transmitter sending 2 simultaneous packets on different frequencies, and the receiver is listening at 2 different frequencies for these packets. And we can see here LQ is pretty much 100 all the time, and sometimes blipping to 99, even when the quad's initially on the blocks. When it's on the blocks, it's down low, your reception's a bit worse, people around you may have telemetry, and the LQ is still phenomenal. All of this DVR is at 1000 Hertz, and it's all done at 10 milliwatts. The race event I was at, we had about 23 pilots. We were doing up to 7 up racing, so at least 7 transmitters on. Who knows how many other transmitters are on in the pits, but there's plenty of packets flying around and plenty of interference. So Gemini Mode is looking pretty promising if you're in a heavy RF environment. Looks good in racing. Whether or not it should be used or allowed is another thing. That's up for discussion. Anyone doing long range work, cine work, may be really beneficial to secure your link. So with all this DVR, I'm using 1000 Hertz. You can see we're getting 2 packets being simultaneously sent, different frequencies. So very similar to D500 in how it sends its packets, but you're now at 1000 Hertz. If you now use Gemini on one of the D modes, D500, you get the advantage of sending 4 packets over 4 different frequencies. Or if you even go to D250, you're now sending 8 packets over 6 different frequencies. Go down to the LoRa modes, you continue to get 2 packets sent over 2 different frequencies. So it should be phenomenal in RF heavy environments or for long range guys. For the DIY guys, I actually haven't done a PCB in a while, and JLC came to the party and helped me out with this, so definitely go and check them out, and I'll leave some links in the description. But here is the there we go. Here is the transmitter. So it's based on a Pico D4, this is all pre-assembled. And on the other side, this will look familiar to anyone who's done DIY work. A couple of E28s. You can stick a little ESP01F down here if you want the backpack. And if you wanted to do a LED, you can do that here. Broken out LED on this side. So if you want to do the LED mod for your transmitter, to bring the RGB to the front, you can see that and see what's going on. There's my other trusty TX16, and this is what it looks like. So it's an internal module, pass-through flashing, up to 250 milliwatts or higher if you know what you're doing. I only ever run this at 10 milliwatts because frankly that's all I need when I'm running Gemini mode, wherever I'm flying around the park or at racing. So if you guys are interested, this is up on Easy EDA. I'll do links in the description, and we will see if there's any interest here and if we can go forward and do something. So to finish up, guys, I'd be really keen to see what your thoughts are on this. Applications, where would you use it? What sort of environment? Is it legal? If you're going to discuss that and start talking about it, make sure you reference yourself. I want to see links to any documentation. Alright guys, if you made it this far, cheers.